statistics today. Guys, let me tell you, statistics in the very start, it might sound boring to you. I'm just letting you know, okay? So just bear with me for, let's say, 1 or 2 hours. After that, when everything starts making sense to you, you will not find it boring, okay? So just wait till we are going to connect the dots. What is the use of what, okay? Yeah, I'll share the drive link as well. Just give me a moment. Start, it might sound boring to you. I'm just letting you know, okay? So just bear with me for, let's say, 1 or 2 hours. After that, when everything starts making sense to you, you will not find it boring, okay? So just wait till we are going to connect the dots. What is the use of what, okay? Yeah, I'll share the drive link as well. Just give me a moment. Skills slash, and this is 27. Standard normal distribution. Okay. So as you guys know that we have read the data set, we were trying to change the type. Okay. Chalo. Just give me a moment and just let me know, okay, where we have stopped the session in the previous lecture. Because as I remember, we were unable to plot the graph, right? So yeah, you can see import pandas as PD. For reading the data set. We have read 2 data sets, Glexo and BML. I hope we are all together till here. Now we have seen what is the Glexo data set. Let's focus on one thing, the date time format. Okay. As you can see, it is in the DDMMYY format. Okay. This is for Glexo. If we similarly look into the BEML data set, let me show you BEML data set. BEML_DF. You will see the format is completely different. It is YYMMDD. Okay, so we have to make them come in the correct format. Then only it is going to work. Okay, so which one is the correct format? You guys need to understand one thing, that this YYMMDD is the correct format for pandas. Okay, when we talk about the standard format of storing the values inside the data set, or let's say changing the format from our data set in the date time manner. So we have to follow this particular format, which is YYMMDD. So as you guys can see, we have to change the data type. Let's say we have to change the format of this Glexo data set. Okay. Now, you guys have seen that we have also changed the Glexo data set. What you can say. Just a minute, let me run it once again. Okay, we have also changed the Glexo data set date time format. Let's say Glexo_DF.dtypes. Glexo. We'll go slow, okay? Now you can see it is in the date time format. Simple. Okay. Once you guys are done converting this into the date time format, understand that why this warning is coming. The reason is that it is telling you that, okay, we have converted your date time format. Sorry, we have converted your data into the date time format, but the warning is coming because the format is not correct. What I told you, the format is going to be correct when you are going to write YY, and DD. Okay. So this is the correct format. As of now, it is showing DD and then YY. So we have to change it into this format. Okay. So I'm just scrolling it down. This is a BML data set. We have also changed the data BML date column into date time format. You can see I am going to run this. You will not find any sort of warning or error here. Why? Because the format is correct. But in the Glexo, you were facing the challenges. You will see the warning. Why? Because it is telling you that the format is not correct. Okay. So what we have to focus on, we have to change the format. Since the data type is already changed, now we have to change the format of the Glexo date time column. Okay. I'm just deleting this one. Okay. So for changing the format, you can see I am changing it to YYMMDD. So this command, maybe I can see you guys have missed it. That's why I'm giving it to you. Simply change the format from Glaxo_df dot YYMMDD format. Simple. Okay. So I'm just giving you a moment to change it. Meanwhile, let me change it as well to check if it is working. And similarly, I'm doing the same thing for the BML for the safer side. So you can see we are having the data of similar type of values. Okay. Where we have stopped the lecture, guys. I hope you haven't covered this part, right? This thing you guys have not acknowledged it yet. This is what I am thinking. I don't know if it is true or not. What I can do is let me share this similar notebook with you guys. You can directly work with me. Let me share. And who all are there who in the statistics? Okay. And we are doing the case study on standard normal distribution. For that, we have picked two stock market data set. The stock market data set name is Glaxo and BEML. They both are real-time data. Okay. Now, basically, while reading the data set, I can see the date time format was a bit different. So we are trying to treat that particular column. Okay. Once you are done formatting the date, are you done formatting the date?
Not yet.
Okay. So let me tell you, don't format it then. Just simply make the date of Glaxo same as date of BEML. Simple. Why? Because even if you do the formatting, you will see the combination of month and date is again shuffled. Okay. So we can't afford to read that again. Simply what we are doing, because they both are same date data set, that's why I'm just assigning the BEML date to the Glaxo date with the correct format. Now you will see the Glaxo is coming in the correct format along with the BEML. Simple. Just don't okay. Now if you look into BEML, you will see they both are having the same data or same data. Okay. And this is what our priority is. Simple. So what I'm suggesting you guys, after changing the date time format, simply write BML of DF date and make it equivalent to Glaxo's date. Just do this.
So can you show the code for converting the date to time, date time format?
Yeah, that is PD.date time. Yeah, this one. Okay. You have to perform the similar thing for the Glaxo as.
Down.
Okay, after this, what you have to do, you have to perform the similar thing for the Glaxo data set. And then you have to assign if you don't want to change the date time format, guys, you can directly assign the date of BML to date of Glaxo. Simple. Do this thing. Okay. You're getting attribute error. Just Prathinav, then don't do it. Just directly do this line. Okay. Perform this line. Do it quickly, guys.
Please go up, go up.
And if you're getting stuck, then let me know as well. The most important thing which we have to do is the plotting of the graph. Okay. You have to read the stock market data set. Guys, are moving forward. Okay. Now we have to plot the graph. For that, we are writing import matplotlib as pyplot as PLT. You will see the data and command for the Glaxo data set is correct. This is just I have given it a try. Okay, so I'm not writing the code once again. We can do the similar thing for BML data set. Okay, so Glaxo is the data set which was creating problem for us. I'm just plotting the graph with the help of matplotlib. Here you can see I'm taking the help of subplots for plotting this. Okay. Subplots why? Because I cannot plot both x-axis and y-axis altogether. Okay. In the dot plot method. So I am taking the help of PLT dot subplots. Inside that, I am writing figure comma AX. AX dot plot. I'm mentioning the date in the x-axis. I'm mentioning the closing value of the stock in the y-axis. You can see, according to the year, we are getting the graph. Okay. I'm just enhancing the size of this graph. So PLT dot figure. This is nothing new. You guys have already gone through all of these codes. Okay. FIG size and that is 18, 15, 5. Okay. Also, it is grid line graph. Let's okay. This is the grid line graph. It will not enhance the size. Let me zoom it. Okay. And just give me the confirmation on the thumbs up once you guys are done plotting this graph. Okay. I'm waiting for a confirmation, then only I'll proceed. Okay.
Yes.
Already? Yeah.
I'm actually trying to plot it with PLT dot plot with the same variables date and close.
And
But-
that is not going to work. Let me tell you why.
Yeah.
Because you can see we are using x-axis and the date and y-axis as the close value. Okay. Whenever you plot two axes with the help of PLT dot plot, okay, what will happen? It will not pick up. That's why we are taking the help of sum, which means one plot is going to get created with x-axis, one plot is going to get created with the y-axis. Then only it is going to mark some points and it will give you the line like this. Okay. So whenever you want to plot with two variables, you have to always take the help of the line graph. Okay. Previously, you guys have seen the line graph only with one column, right? We are doing this two column combination. So for the two column combination, you have to do somewhat like this. Okay. Okay, we already received 2 thumbs up, 3 thumbs up on that. What about rest of the people? Teaching here is very important. Okay. Now we will read the data set. Let's say read the graph. We are having overall 29 exceptions are there. Let's say 5 or 6 people. What about rest of the 20 people? Are you guys trying? I only received 3 confirmations. You want me to wait? Okay. Please wait. Okay.
Even after actually using AX plot, I'm getting still that weird graph.
Since you are able to plot this graph, let me tell you one more thing. We are having two data sets, right? As I told you, there are two stock market data sets. The first one is the Glexo. The second one is the BML. What is the ultimate goal, guys? We have to understand because this is intraday trading. Okay. What is intraday? Intraday means we are using, or let's say we are investing in the stock market on a daily basis. Okay. Let's say you invested some money in the morning. Whenever you feel like that the stock is going up, with the prediction, you are pulling the money out. Okay, that is intraday, within a day. So the stock markets or traders, they work like that they are going to invest money today and they are going to leave it on the day when the profit or the stock is going to come. Okay, that could be 1 month, 2 months, in the span of 6 months as well. Okay, so that is not intraday, that is normal trading. This is intraday trading. Within one day, you have to invest in stock and you have to pull the values out from the stock. Okay, and it has a higher risk, guys, to be very honest. Okay, as I told you, standard normal distribution is the type of a concept in the statistics which widely gets used in the financial industry. Okay, when I'm talking about financial industry, which means whenever we have to identify the pattern within the stock markets, also whenever you want to find the pattern within profit and loss, whenever you want to see, let's say, supply chain values, some type of values, or let's say some type of data, the standard normal distribution is very important. Why? If you guys remember, once we imported these two data sets, I told you one thing that we are going to identify which stock is profitable, right? Which means if given two stocks and we have given the data of two stocks of same date, we have to judge which stock is profitable. Okay. So for judging the profit, we have to extract the gain value of the stock. Okay. As I told you that it is intraday trading. So we have to identify the gain according to the daily basis. Okay. Let's say in day one, what is the gain percentage? In day two, what is the gain percentage? In day three, what is the gain percentage? So we have to do the same thing for the Glexo. We have to perform the same thing for the BEML. If I'm going to extract the gain, if I'm going to extract the gain, then only I'll be able to judge which stock is profitable among these two. Okay. So to identify the gain, we will come back here later. Just come back here in the pattern of the stock. Okay. Looking at this very carefully. If I ask you that, what is the highest, let's say, the year where the stock market, or let's say the Glexo data set, reached the highest closing price? What do you guys think? Which year it is? If you look into this stock, it was very low at, or let's say on 2010. And then I can see the patterns are coming, growing up, down. Where this graph is reaching the peak, it is somewhere between 2016 to 2017, quarter of 2016, we can say. Okay. So it is reaching the peak and my stock is going above 3,500. The value of the stock is going above 3,500 for the Glexo. Now we are going to plot the similar graph for the BEML data set, just to identify the trend that if it is the same thing for BEML also, let's say on 2016, my BEML stock also hit the peak price. Yeah, are they going hand in hand? What is the pattern of BEML data set? Okay, so for that particular thing, I am again plotting the graph. Okay, simply writing figure 2, AX by G, AX2 equals to PLT dot subplots Again, telling you guys, why we are using PLT dot subplots, because in PLT dot, let's say, matplotlib.plt, whenever you want to graph, let's say, whenever you want to plot the line graph, PLT dot line or normal PLT, it is going to only accept one axis. And it will give you the proper line graph. Okay, but here we are giving two axes, both x and y. So for that, I am saying plot the graphs separately. Subplot means it is going to plot two graphs. Okay, one graph with one axis, another graph AX with both the axes. Okay, so it is just overlapping of two axes happening to see this graph. Simple. Okay, now after that, I'm simply writing AX underscore 2 dot plot. My data set is BEML underscore DF, and date is the column for the x axis. BEML underscore DF, close is the column for the y axis. Running it, you can see. Just let me zoom this out a bit. We are having the data set somewhat like this. Otherwise, if I ask you the same question in the BEML data set, what do you guys think? What is the peak year? Or let's say, what is the year where we reached the peak price? You will see it was coming near to the half year of 2015. Okay. Previously, my Glaxo stock reached the peak after the quarter of 2016. Here in 2015, mid, we are reaching the peak, the BEML data. Okay. And you can also see it is constantly growing. Right? You can see now it is going down. Previously, we can say that the Glaxo stock was constantly going with bit of up and down. But here you can see the mid fall, right? We are having the high fall here, then high rise here. Seems to be a bit risky. We will understand this. Okay. As of now, just for the understanding, I'm telling you. If you read this graph, you will see we started from 1200. Okay. 2010, the price was 1200, and later the stock was going in so much loss. But in 2014, it reached the value of 200 as well. Okay. Then after 2014, we somewhere reached the peak, and in mid of the 2015, the stock price was very high, somewhere near about 1500. I can still see that Glaxo stock was very profitable, because even if it is reaching the peak and the starting price is 1500, it is twice. Okay, but this is not the case. It is not the twice. If I'm investing 1200, you can see the pattern. What is the value going up and down? And it's not even reaching to the peak of twice of 1200. Okay, here it is, of course, reaching the twice, but here it is not even reaching the twice. It's just going with a profit of 200 or 400. Simple. Okay, so we are not making any sort of conclusion. We are just reading the variation in the data set. Okay, with the help of date and closing price. Simple. Making sense? Now we will talk about gain in the stock. Very good till here. Shall we move forward? Chalo. Now we'll talk about gain price. Okay. So for talking, when we are talking about gain price, I'm simply writing Glaxo underscore DF. You can see this is your data set. Okay. Now once you will extract your data set, previously we were working on the two columns. Which two columns? Date and the closing price. Right. So you can extract these two values out of the data set and work with it. You can work with whole data set, and it will become too complex for us. So I'm just extracting these two values so that I can create one more column for the gain. Okay, what is the intraday gaining? Let's say according to the close price, we are going to judge the gain and loss. It we will see later. But as of now, let's just extract these two columns. Okay, so how we are going to extract it? Simply, you can take the help of log as well. I can see previously guys are facing the challenges. So simply I am writing Glaxo underscore DF. Column number 1 is your date. Another column is your close. Now I'm modifying my variable like this. Even if you look now, Glaxo data set, it is going to look like this. Now you have to perform the same thing for the BEML also. Okay, these two data set is running hand in hand. So the thing which we are doing for data set 1, the similar thing we are going to do for data set 2. Simple. Just giving you a moment to absorb this or to jot it down. Okay, now we will try to answer some of the client questions. Okay, and we will, along with that, we will also see what is the application of standard normal distribution in this case. Okay, so I'm writing down some questions. Let me mark this down. Let me tell you guys, this is going to be very common. For every topic of statistics, we are going to do the case study. Okay, I'm just telling you to revise the plotting libraries along with the basics or basic command of pandas. Okay, that will be very helpful for you. Now, what I'm going to do here is just give me a moment, okay? Meanwhile, jot this down. Sorry guys, today you have to bear with me. I'm expecting two or three more bells within the time span. Okay? Yeah. I hope you guys have jotted it down till here. Now, Okay, I'm getting only one question. First, we will answer this question, then we will hop into the next one. Okay, what is the expected daily rate return of the stock? Do you guys understand one thing? Suppose I'm going to choose this Glaxo data set. Okay, here I am pasting it down. Now you can see it only contains two columns, right? The column number one is your date, and the another number is your closing price. Now it is asking you expected daily rate return, which means what it is talking about, guys. What do you guys understand from this? Daily rate return,
Gain percentage.
gain percentage. Okay, on the per day basis it is talking about. So see, the closing price of the stock was 1625 for day one. Now the closing price of stock for the second day was 1616. You can see there is a difference. And here it is going in the bit of loss. Okay. So we are going to calculate the gain percentage. If the gain percentage is in the positive, we will see it is a profit. If it is in the negative, we will say it is in the loss. Okay. So we are going to find the gain percentage. Understand this. Since those who are good with the quantitative aptitude, they must be knowing the formula for calculating the gain percentage. If you guys not having the idea, let me show you how we can calculate it.
Megha,
Yes.
yeah, Megha, just a question. This is for intraday, right?
Yeah, correct.
I guess the gain percentage would be open minus close something, right? For that day.
Oh, open minus close for that day. Okay. Now let me tell you the opening price. Here, if you look into the data set, this is a very great question. Okay, it seems like you do trading. Just a minute. This is, let's do this better. Yeah. So this is the opening price. This was the closing price. Okay. Now what it is asking you, expected daily rate return of the stock. Okay. Which means, suppose this is your closing price, right? The next day, the starting price was 1639. You can see it is getting variable every time. The closing price is something we say that by the end of the day, it was the price of the stock. Okay, and this is the closing price. Even if you don't want to pull your money out, but since you're intraday, you have to end pulling your money out within this. The next day, the similar amount goes to 1616. So, what is the rate of, let's say, gain of the stock we are talking about, not on the basis of the person? Getting it? What is the gain percentage of the stock? We are not talking about the gain percentage which people are achieving. Because you can see, we have opening price, we have closing price, high, low, last. But do we know that what person invested and where the person invested? No. Within the day, the prices will go up and down. We are not having the entry where the person invested and when the person pulled it out. Okay? Just a minute. I hope I'm making some sense.
Yes, yes.
Yes. So I hope I am making sense. It is talking about the daily rate of these. Okay. How stock is growing. Okay. We cannot judge this with the opening and closing price. We only can judge this with the closing price.
So last row 1738 will be empty, right? So you will do backfill for that.
Which one?
Use this
This is-
concept. Yeah. from the previous one. So the last 1738 column, row will remain empty because we do not have the data for the next day, right? So,
So let me tell you. Yeah. So you are very close. Okay. The entry which is going to be null for the gate is going to be the first row. Okay. We are going to deal with that. Don't worry. The last row will get the value. Let me tell you how we are going to calculate the gain percentage. Okay. So the gain percentage gets calculated. The closing price of the T value, or let's say T entry, minus closing price of T minus 1 entry. This is how you calculate. Usually also we also calculate the gain like this only. The closing price of T minus 1. Understand this. Suppose this is your Tth entry. Okay. Do we have any T minus 1 entry? No. So for this entry, we will be having an AN value, not a number value. Okay. That is going to be blank for both Glexo and BML. Now you will find the gain percentage from this entry, because this is going to be your Tth entry. And now you have T minus 1 entry. So you can see the gain percentage between these two entries. The first entry will go blank. Rest of the entries you will be having gain percentage. Okay. Making sense?
yes.
Okay. Let me erase this. I hope you guys understood the formula. This is how we calculate the gain every time. Okay. Since I am not multiplying this with 100, it will not give me in the percentage format, but it will give me in the point format. Okay. Let me erase this. Let's go here, and let me tell you very good thing that you don't need to write function for this. We already have this thing available in the Pandas script. Okay, so simply I'm going to write one thing here, that is going to be your data set called as Glexo underscore DF. And the column name which we are going to give is the gain. How this column is going to get the value? From the data set. Okay, what column we are picking? The close column we are picking. Understand the command very carefully, because the next DML thing you have to do. Simply you have to write .tct change. Okay, because it is going to tell you the percentage change between the entries. You have to also give the entries, right? Pandas or Python does not have knowledge what type of entries you are talking about. So you have to tell them that please change. Okay, so .tct change, I'm writing for it. And in the command, if you want to see the Glexo data set, you can see this is how it is looking like. You can see first entry is coming to be NAN. Next, you will see it is giving me the gain and loss for every entry. Okay. similar command of that formula. Okay. Whenever you want to find the percentage change, it's not here they are talking about the closing price. Anywhere, whenever you want to identify the percentage change, you can take the help of this command. This will help you to calculate the percentage change from the previous entry, because you are mentioning period is equals to 1. So whenever you are going to do that, it will consider your this entry as the Tth entry. This is going to be a T minus 1 entry. It is going to calculate the percentage change on these two. Since once it is done, then it will calculate the percentage change in these two, and then in these two, then in these two, likewise. Okay. No problem. Please write the similar thing for BEML as well. Do the same thing for BEML. Okay, we have to keep both the stocks hand in hand. So simply writing BEML of DF, again mentioning the column name as gain, and BEML of DF, the closing price, dot TCT change, and period is equals to 1 again. It BEML. Okay. Let me check BEML on DF. Yeah, it is coming. It's giving some weird warning, but ignore it. So for Glaxo and BEML, we drafted the gain column, where the first entry is blank. Okay. Now we will drop the first entry, very basic. You can see for both Glaxo and BEML, we are having NEN for the gain percentage, right? So understand one thing, guys. We have already answered question number 1. What is the expected daily rate return of the stock? This question is answered. Okay. Just to make this question get answered in the correct format, we are going to drop the first row. Okay. Because you can see the gain entry is null here. So I'm just going to write BEML underscore DF dot drop NA and assigning it back to the BEML. Same, I'm going to do this with Glaxo. You guys must be knowing, right, how drop NA works. Wherever it is going to file the null entry, it is going to drop that particular row. Okay, by default. You don't need to mention access or anything. Okay. Run this. And now if you check, your data set will come in the proper format. Minus is showing, guys, that you are having loss. Okay. And plus is showing that somewhere you are going in the profit. Understand this. We'll try to answer second question, okay? That is the important one. And here you will see the concept of standard normal distribution coming into the picture. We good till here? Okay. Since we are good till here, let's scroll this a bit up. Let's write the question number 2. The question number 2 says, read the question very carefully. Which stock higher risk or volatility as far as daily returns are concerned. Let me check this one. Concerned. Okay. So if you read this question carefully, what it is trying to say, which stock have higher risk or volatility variation as far as the daily returns are concerned. Daily return means gain. Okay. So judge the gain of your stock and tell me which stock carries the higher risk. That is what the question says. But we have to judge which stock carries higher risk. Okay, let's try to solve this question. Okay, so basically, I will find the mean of this column. Once identified the mean, I will then address and find the difference between the data point and the mean. Okay, so whatever the difference is going to be, that will become my one entry. Likewise, we are going to have overall 1738 entries. And the average of those 1738 entries is going to be the standard deviation. Okay, so there is a basic difference between variance and the standard deviation, and the basic difference in the calculation as well. Variance is for every data point, standard distribution says for the whole column. Okay, now, let me erase this. Just to answer this question, that which stock have higher risk, understand that if you guys remember, in the starting of the session, I told you that the standard normal distributed data set is, or let's say distribution, is highly popular in the field of finance. Okay, whenever you want to judge the high risk, high profit, high loss, you judge on the basis of standard normally distributed data. Now to plot the graph of standard normal distribution, which plot we are going to choose, guys? Which is the plot for SND, sorry.
Gain.
Okay, gain is going to be the column and will become one of the axes. Okay, but what kind of graph we are going to create? You guys know there are different type of graphs: bar graph, pie chart. Which graph is the suitable for SND? Sorry. Batao.
PDF.
PDF. Very good. Very nice. That is the probability distribution function. What all you are telling is perfectly fine. Just understand there is a basic difference. Okay, PDF is the probability distribution or density function. Okay, this is going to be your y-axis. Somebody said gain. That is going to be your x-axis. Okay, what is the plot? What type of graph we are going to plot between this x-axis and y-axis? Histogram is not the correct answer. Sorry?
CDE. Sorry,
Okay.
KD. Kernel test.
Right. Kernel density estimate graph. Okay, guys, and keep this graph in your head because you are going to acknowledge this graph very frequently. Okay, so kernel density estimate. This is the name of the graph that helps you to plot the distribution. Okay, in the standard normally distributed format. In the x-axis, you are going to have the column of your own choice. That should be continuous type of numerical random variable. And in the y-axis, you will be having one probability function. Here in this case, depending upon the type of data, it is probability density function. Now guys, understand this. We cannot plot this KDE graph because you guys know that PDF is something which we cannot directly plot or graph with the help of matplotlib. I told you in the session number 1 that whenever the case of complex graph comes into the picture, we choose CBOT. Whenever the basic graphs with the help of two axes we want to plot, we choose matplotlib. KDE, even if we try to plot, hold for a minute. Even if we try to plot KDE with the help of matplotlib, it is not going to work because PDF is something we are going to miss that. But in the case of Seaborn, it will give us the better view because it is kind of a complex. Just importing the Seaborn. Yes. Who was that?
Yes, I was going to say, once we first clean outliers before doing some normal distribution.
Okay. So as of now, in this case, let me show you what type of outliers we are having, and that outliers are important to keep or delete. Okay. So basically, on the basis of that, we treat outliers, not every time. Okay. So in the upcoming lectures, we will talk about when to treat outliers and when not to. As of now, just drop the idea of the outliers. Okay. I'll show you what outliers are, but we are not going to treat them. Okay. The major concern here is just to answer this question, that which stock has the higher risk. Okay. So just scrolling it down, now we are going to plot the KDE for both DML gain and the Glexo dataset gain. Okay. After plotting the graph, then we will see what is the actual difference, and along with that, what is the risk in both the graphs. So simply after importing the Seaborn, I'm writing SMS dot dist plot, that is distribution plot. Inside that, I'm going to mention my column name, Glexo underscore DF gain. Okay, just giving the label as it's. Okay, running it, you can see we are having the graph somewhat like this. Okay, now the similar way we are going to plot the graph for DML. I think that within the same cell so that we can do the comparison very easily. If they are going to come or fall within the same axis, it will become easy for us to do the comparison. Simply writing gain, and then label is going to be DEML. Okay, we can see we are having the graph like this now. Excuse me. Now, the major issue is we have to read the graph, how this is working. Okay. For that purpose, first I'm just enhancing the size of the graph. plt.figure, IG size 15,5, closing it. Okay. Now you can see I'm just changing the color as well. Okay. Color is equals to red. Here I'm writing, keep the color here. Let's make this black. Now you guys can see along with the KD, we can also see the histogram coming into the picture, right? Simply I'm writing hist is equals to false for that. I want to see the normal KDE. I don't want histogram to come into the picture. For that, I'm mentioning histogram is equals to false. Now it is looking like a proper KDE graph. Okay. Even if you want to keep the histogram, then no issues, because I just want to tell you that's why I'm keeping the graph like this. Okay. Just a minute. We have option of fills. SMS dot test. KDE, rank, fit, color, vertical, normal hist, X label. Wait a minute, okay guys, just a second. No. We cannot fill. I guess we can, but maybe whether the blood caution color density comes baby blood color vertical normal wrist. So leave it. Okay, I just want to fill the color between this graph, but let it be. Here, now if you look at this very carefully, we are having the red color graph as the Glexo and the black color graph as the BML. Okay, now look into this very carefully. Guys, if you look into this, do you understand one thing, that we are having the centermost, or let's say the center of the data coming here as 0. Mean is equals to 0. Okay. Now, if you want, you can check the standard, if you want, you can check the statistical overview of the column gain as well. Okay. Let's say BEML underscore DF, the gain column. And I'm simply writing dot display. Okay. Now you will see it is giving me the statistical overview of data. Guys, can you tell me that is mean is equals to median? We know which one is the median from here?
50%.
50%, right? So now you can see it is somewhere near to equal. It is 0.00271. It is 0.001541. Okay. But you can see hardly there is a difference. And I told you that you will face this type of difference very often. Okay. So it's nothing to worry about. Usually we can say that it is a bit standard normally distributed. Since we are having the tail in the data set, that's why I'm assuming that it is standard normally distributed. Okay. Why it is not normally distributed? For normal distribution, mean is equals to median. Whatever the value of mean is, it should always be equals to the median. But when you are having standard and normally distributed data set, your mean is equals to 0, and you will see the standard deviation near about 1. Okay. Here in this case, I can see the mean is approximately 0, and the standard deviation is not near to 1. Okay, so that's why I'm saying that we are assuming, okay, that this graph is standard normally distributed, because some of the parameters we are having, rest of the parameters, they are missing. Okay, so just basis of some assumption, we are saying that it is standard normal distributed, just to avoid it as of now, okay, because my concern is something different. Look into this very carefully. The standard deviation for the BEML data set is 0.026. Okay. Now, for standard deviation for Glexo data set is 0.013. Okay. Now, understand this thing very carefully. What is the meaning of standard deviation here, and how it is going to answer our question? Okay. So just for our confirmation, let me tell you that we are assuming that it is normally distributed or standard normally distributed. Okay. Now, just to answer this question, you can see that after finding the standard deviation, the expected daily return is around 0% for both the stock. Okay, because your mean is 0. That's how we judge the particular column, right? We cannot check the entries one by one. So if somebody asks you what is the average return of the stock on the daily basis, you will say it is somewhere near to this. Okay. Now, here the standard deviation, which you guys can see. What is standard deviation? Usually we say that it is the dispersion of the data set. It tells you that how the data set is distributed. Okay. So the standard deviation of BEML stock is 0.0264. The standard deviation for the Glexo stock is 0.013. Now, guys, could you please tell me, having standard deviation high in my data set, is it a good thing or a bad thing? What do you guys think? Having high standard deviation in my data set, is it a good thing or a bad thing?
Should be a good thing, right? Because it's telling that.
Okay. No, don't worry. Don't look into the comment section. Just tell me why you think it is a good thing.
If it's low, if the standard deviation is low, it should be a good thing, right? Because
Low is a good thing.
it's not a good thing, or I didn't hear what you said.
Okay. Now issues. Admit